Very good. My name is Rick Fellows. I'm also with KMC Controls, VP of Business Development. I also do regional sales management for the Western States. I live in the Seattle area. I'm not back at the factory for KMC Controls, which is in Indiana. I live up in the Seattle area and handle regional sales management for the Western States. So this is about BACnet basics and beyond. So we're going to be covering the learning objectives here is the history of BACnet and open systems, what they really mean, where they came from. We'll also talk about what is BACnet, its strengths and weaknesses, which is really its structure as far as LAN types and objects and properties. We'll talk about some of the ways that we can exploit some of those strengths that it has, the actual strengths of the BACnet protocol, as well as some of the obstacles that you'll have when you're doing operations and interoperability within your facilities, what some of those obstacles are and how to overcome them. So those are the main learning objectives. So really where digital systems came from is pneumatics. Back when we had pneumatic controls pre-1980, pre-1980 was predominantly pneumatic controls, even though today we still have a lot of pneumatic controls installed in the United States. Pneumatic controls were the first interoperable system. I mean, they were the actual epitome of interoperability. You had 20-pound supply air, and as long as you had 20-pound supply air, you had a thermostat that you could buy from Johnson Controls, Robert Shaw, MCC Powers, Honeywell, and you could connect that up to a valve or a damper actuator, and you could make it work. You didn't actually have to have the products all made by the same manufacturer. So you had that interoperability and interchangeability. And that also allowed for competitive bids. You could actually put in a wing or the initial building, might be a pneumatic control system by brand X, and later on you could add a new wing to that facility by going out for competitive bids and expand it with brand Y, because all you really needed was 20-pound supply air. So you had that interoperability there. Now, of course, you had to pay for maintenance on those systems, and a lot of times the maintenance of those systems was quite expensive, but you could have interoperability and interchangeability. If you had a Honeywell thermostat, you could replace it with a Johnson Controls thermostat and make it work. But then, back in the 80s, we started having digital controls. Really, the first things that came out were what were called hybrid systems or energy management systems. You heard that a lot. And basically what they were smart time clocks. There were time clocks that would tie on to your pneumatic control systems, but they added things such as optimum start or demand limiting. They actually could do demand limiting overlays into your existing pneumatic control systems. And today you can still do that. You can still do that for existing pneumatic control systems, but you lose a lot of the advanced capabilities of a true direct digital control system. But back in the mid-80s, or the early 80s, we started with these overlay type systems. Later on, by the mid-80s, we actually started having true direct digital control systems. My explanation for direct digital controls is slightly different than Ben's, but direct digital controls is really where you have the digital control system doing the control directly. It's not an intermix with the pneumatic control system. You actually have a small microprocessor on a circuit board that is measuring temperature or pressure from a sensor in the room, and then it's controlling the mechanical equipment directly. So it's actually direct digital control, and that's really where the term came from. It really allowed some really neat things, though. Once you had direct digital controls, then it was really just sensors coming into a control board and control devices connected up to that same control board on the output side. But then the software you could write, you could have very, very complex control sequences to help save energy, increase occupant comfort, increase indoor air quality. So that's really where direct digital controls came from. And the nice thing about them is it does allow things such as remote troubleshooting. It's very easy. You can see what's going on in the building and actually have centralized monitoring of these systems. Those started in the 1980s, but the problem was there was no compatibility. Everybody built their own. Everybody built their own digital control system. Brand X was not compatible with brand Y at any level virtually. In the very early systems, even the temperature sensors were not compatible, but from one brand to the next. They all used different resistance values or different voltage values, and virtually nothing was compatible. So really what happened then is you were tied to that manufacturer. There was no interoperability. If you went out for a expansion bid and wanted to expand your facility or remodel part of it, you had to go back to that original manufacturer because there was no interoperability within the systems. And that really accounted for some very, very expensive expansions. And also very expensive service agreements because you had to go back to that manufacturer to have the service of that system done. And that really caused a lot of grief by the mid and late 80s. And that's really where the birth of open protocols started. By the late 80s, there were some people at Cornell and within ASHRAE that got together and were thinking about ways to make digital control systems back again like pneumatic control systems, where you had interoperability, interchangeability between sensors and controllers and software. So you could actually have that interchangeability and again drive the cost, bring the cost of these systems back down. So that's really what kind of drove it, and there was a number of different interoperable and open protocols were created at that time. So really, what are they? What are open protocols? It's the Building Automation Control System Communication Standard. It allows, again, the small microprocessor boards that are scattered throughout the building, it allows those to share information directly. They can talk directly, they understand the same language. You don't have one controller board speaking French and the next one speaking German and they can't understand each other. They all speak, they all speak French or whatever language it happens to be. And again, that allows then the interchangeability of those controllers. If you have a controller fail, you don't have to replace the whole system. You can actually replace just the controller with a different brand if necessary. And that helped free the owner from the vendor. Now you could go out for competitive bids for expansions and keep the cost of your total cost of ownership down in the system. Two of the most widely used and adopted open protocols that are used in the commercial controls industry today are BACnet and LAN. BACnet is the protocol that was created by ASHRAE. Again, that was some people at Cornell University as well as some individuals within ASHRAE got together and decided to come up with an open protocol. LAN is basically made by the Echelon Corporation. It is a communications chip, and it attains interoperability by all controller boards use the same communication chip. So that's the difference between the two. So why should you specify and use open protocols? Well, again, interoperability, interchangeability. That's the thing I'll keep saying and you'll hear a lot of. Better service and support, though. Now, a contractor that's supporting and servicing your system has to earn that respect. They have to do a good job for you to keep coming back to them because you're no longer tied to them if you're using an open protocol. So you usually end up actually getting better service and support out of your service contractors. Of course, competitive bids for expansions and lower, all of those things together result in lower total cost of ownership, which is, I think, what most of us are after. So here's some of the pop quiz things we have here. What is the reason for specifying open protocols? My favorite is A, but it could actually be F, all the above, right? But most of those, C through E, kind of combine together and give you lower total cost of ownership, which is the overall thing we're after there. So we're going to talk about BACnet now. Really where it came from is, and what the definition is, it's a data communication protocol for building automation and control networks. That was the overall for our definition, and that's really where the term BACnet comes from as well, building automation control network. Again, it was created by ASHRAE. It is still governed by ASHRAE. It was first published in 1995 as SSPC 135, one of the standards that ASHRAE created. It took them 8 years. So 8 years before 1995, they actually started creating that protocol standard. They gathered together people from the industry, other manufacturers, people within ASHRAE that understood mechanical equipment, and they all got together for 8 years and pounded this thing out, and everybody's kind of got their own little aspect of their system probably in the BACnet standard, but it's a nice standard. And it's basically just a book that you can buy from ASHRAE. So you can actually buy that book, and that book tells you everything about how the protocol is supposed to work on in computer software, in the microprocessor boards for your DDC system. That book defines that. So it's not a computer chip that you buy. It is actually just a protocol standard. Okay. The real parts of it that are important, that actually give it its strength, is that it has two parts that it covers. It covers both the transport part of it, and that's like the mail system. You know, when you have our mail system is wonderful today. I mean, a lot of people complain about the fact that it costs 35 or 45 cents to mail a letter, but can you think about it? You can actually write an address on a letter, and for 45 cents you can have it delivered clear across the United States to somebody within a few days. That's actually, to me, pretty amazing. What BACnet does is it provides that transport level. It actually defines how that piece of information is going to move from one place to another. It defines the wire types, the actual packets of information, how it actually gets transported. But the other part of it is, the other part that's probably the most important, is it also specifies the application package, or the application message. The application message is what is written on that letter inside the envelope. So that when you mail that letter from France to Germany, the guy in Germany opens it up and it's all written in French. Maybe he doesn't understand it, but if it's written in a common language, he can understand it once that letter gets to him. And that's probably one of the most important parts, and that gives the important strengths of BACnet, is that the application message is completely defined. And it's the same for all manufacturers. Everybody uses it because that is part of the BACnet protocol standard. So really, digging down into that actual message there, the application message, it's all based on what are called objects and properties. And we're going to cover objects and properties and what those are. They're things like an analog input where you measure temperature. It also defines all the services that are necessary for building automation systems, such as time schedules or alarm management. How is that all handled? So that, again, all these pieces are interchangeable because they all do it the same way. We'll also talk about the different LAN medias, and there's actually 6, sometimes 7 if you will look at another one, but there's 6 different types of LAN media and why you'd want to use different types. And then also what are device types? You might hear those sometimes, things such as building controller or advanced application controller or smart sensor. We'll talk about all those as well. Well, objects, the BACnet objects are just that. They define the different types of information that are going to be transmitted in the system. Today there's over 50 objects and it's growing. BACnet, of course, is controlled by ASHRAE, and there's a bunch of committees, and they can continue to evolve the BACnet standard as new technologies, new building systems, and new ideas in how you control your building. As those things continue and our knowledge of those things continues to increase, the BACnet standard continues to evolve as well. So right now there are about 50 objects. When the standard was first published in 1995, I think there were 23 objects. So you can see it's almost doubled in that 18 years. But there are things such as analog input or a loop object. That's your actual PID loop, like an old pneumatic thermostat. Notification classes, those are things that have to do with alarms and how our alarms are transmitted. All of these things give it a lot of strength because everybody uses the same object set. Everybody has the same object set and uses it the same way. So objects are just things like an analog input or an output that would be used to drive a variable frequency drive. Then each of those objects has a bunch of properties that are defined for that object. Again, part of the standard. And all the manufacturers then must use the exact same properties of that object. So that's really nice because when that letter gets from controller A to controller B opens up the letter and he knows that it's an analog input object and these are all the properties. And it's the same again for every manufacturer. So for an analog input, you've got things like the present value. And what units is it? Is it that I'm getting a number here at 63.2, is that degrees C, is it degrees F? So your units are all defined. And there's a whole set of, slew of units are all defined in the BACnet standard. But again, that's what gives it its strength, in that everybody uses the same objects and the same properties of those objects. Then in the BACnet services, there's such things as alarm management, so that a building controller or an advanced application controller out in the field, when it sends an alarm up to an operator workstation, that operator workstation could be by a different manufacturer, or it could be sending it out to some kind of a dashboard system, again, by a different manufacturer. But it's using, the sensor, it's using the same methods to transmit that information through notification classes and some of the other objects that are used to control alarms and events and trend logs, things like that. That information is very easily transmitted between all of those areas. Okay, looking at the different transport options. This is the LAN media. Today there are several LAN media, about 6 of them. We have BACnet IP, there's BACnet on Ethernet, there's Zigbee. Zigbee wireless was actually introduced in 2008, so we can actually transmit the BACnet information over a wireless communication instead of actually a wired, which the rest of these transport options are all wired, hardwired options. There's ArcNet, what's called PTP, or point-to-point transport option. That's really just the old RS-232. And there's another one called Mstp, which is really just the old RS-485 or EIA-485. The two that are used the most today in most of the building automation systems that use BACnet is BACnet IP, which is used in the top end of the system, and BACnet Mstp. Those are the most widely used, but just about any control system, BACnet control system you have, may also have some of these other transport mechanisms in there as well. But again, the BACnet standard says this is how you move a BACnet packet of information, all those objects and properties, and this is how you move it on those different LAN media. It isn't different types of BACnet, it's just different wiring types. Okay, so the BACnet IP is used for IP-based WAN systems. So that could be the internet. You can actually use the internet as a communication backbone for a BACnet system or multiple BACnet systems. Also, school districts have IP WAN, so you could actually have the information being transmitted across an IP WAN. When BACnet was first published in 1995, they did not have BACnet IP. It had the next one here, BACnet Ethernet, which is the standard 8802.3. And basically it was how do you move BACnet packets over Ethernet wire. The problem with that is that routers that take information from one LAN media to the next, let's say you've got an Ethernet in your building and you need to get that information to another building across town, you're going to have to go through an IP WAN, such as the internet, to get there. And IP systems, or I should say systems that use IP, such as TCP IP or UDP IP, did not know what to do with a BACnet packet. So that BACnet packet could not go across an IP WAN. And initially they made special routers that understood a BACnet packet, and it would basically take that BACnet packet, wrap it around with an IP wrapper around it, and send it across from that one specific router to another specific router, decode it, and it could be transmitted over that BACnet system. Thankfully, though, the ASHRAE committee decided, well, that's not really a good way to do it, and they came up with BACnet IP. And most routers you have, and most building automation control systems you have today, the BACnet routers that are used in them will handle both BACnet 8802.3, BACnet Ethernet, and they'll also handle BACnet IP, some of them simultaneously, and you may need to do that to interface with some of the older systems that are out before BACnet IP. And then Zigbee Wireless was introduced through Addendum Q in 2008, so now we can actually transmit information from one controller to the next in a building using wireless technology. You should be a little bit cautious about that, though. It's not for every facility. It's not doesn't always work for every layout, so you have to be very careful, make sure that your engineers or people will actually study and make sure that you have strong enough signal from point A to point B, that you have repeaters put in to make sure that the signals get through, and that there's also redundancy in that network. And that's one of the powerful things of a wireless mesh type network, which is the Zigbee Wireless is a wireless mesh, is that if it's designed correctly, it does have that redundancy. So if one piece of equipment fails or is turned off by the circuit breaker, the information is automatically rerouted a different direction. So that is one of the strengths of Zigbee wireless, but it has to be engineered a little bit more carefully than a wired communication system. ArcNet is also used in BACnet systems. It's predominantly used by Automated Logic. Automated Logic, when most of their larger controllers came out, were using ArcNet. Most of the manufacturers use Ethernet. Today, Automated Logic has both ArcNet and Ethernet or BACnet Mstp in those devices, and they can be selected in the field on the fly to use any of those LAN media. PTP, again, is the old RS-232 or EIA-232. It's used primarily in modems and some direct connect devices, where you have a laptop and you need to do a direct connection to a piece of equipment, not using Ethernet, not using MSTP. They'll use what's called PTP. And it's not used that much in systems today because, quite frankly, we don't use modems a lot in these systems today. We used to use modems for remote access. You'd actually dial in with, from home or your work location to a building across town, and you use your telephone system with a modem to make that remote connection. The problem with those systems is they're very slow. And today, most systems for remote connections are actually using the Ethernet, or I should say the Internet, as a communications backbone. So you don't see PTP used too much today in the actual communications, the normal communications of these control systems. And the last one here is, I think, probably the most important, is MSTP. Now that stands for Master-Slave Token Passing. Basically, it's the way that the information is going to be passed on a pair of wires. It uses the old RS-485 standard, or EIA 485. And it's very inexpensive wire because it's a two-conductor shielded wire. It's usually anywhere from 18 gauge down to 22, 24 gauge. One thing in BACnet systems that it needs to be a low capacitance cable if you're running at higher speeds. The BACnet MSTP can go all the way up to 76.8 kbaud, and they're talking about moving that up to 115 kbaud, and that makes the use of low capacitance cable very important. But it's very inexpensive and easy to install. Electricians know how to install it. You can run it through the ceilings right over the top of lighting ballasts and all that, and it works very well. It's also very easy for manufacturers to design the electronics in their circuit boards on VAV controllers and unitary equipment to communicate using the BACnet MSTP standard, the RS-485 standard. So it's very inexpensive for the controllers. It's inexpensive for the wire to actually purchase the wire, and it's also inexpensive to install the wire. So it's used mostly in your terminal unit applications, going from controller to pass information between those controllers. Now, it is not a really high-speed communications LAN media. We're only talking today at 76.8 kbaud. For Ethernet, we're talking 10 or 100 megabaud. So that's really fast. But it works well for the amount of information you're passing between just a few controllers in a network. And they typically go anywhere from 60 to 80 devices on one single BACnet MSTP network. And you have to, because it's the RS-485 standard, you do have to have repeaters every 32 devices. But looking at the different BACnet LAN types then, as you go up a higher and higher speed, you also start to increase the cost. If you're having a bunch of VAV boxes in your building, maybe you have 200 to 300 VAV boxes, and each one of those has a direct digital controller on it. If those were all Ethernet, think about it. You'd have to bring a Cat5 cable back from every one of those things into a switch. So now you have to have, 200 or 300 port switch, or multiple switches that are 6 to 8, 10, 12 port switches, and those all have to be tied together. So it adds a lot of infrastructure and added cost. The cable's more expensive. So Ethernet works well for the top end, where you're bringing a lot of data together, and from all those 300 VAV boxes, they're all using MSTP, but somewhere along the line you're going to go through a router and get it up to Ethernet, so you have the higher speed. BACnet MSTP then is the lowest cost. And it works well for, again, terminal unit controllers where you have not a lot of information being passed back and forth. Does it work well for real high point count controllers, controllers that have maybe 50, 60, 100 points coming in and out of it, say like in a central plant? Probably not. That is still also just a BACnet controller, but you're probably on those really high point count controllers, you're probably going to want to use either ArcNet or Ethernet as its communication standard instead of BACnet Mstp. So looking at a little diagram where all those ride, you've got your workstation at the top. That's where you have most of your data is being aggregated up to that workstation for trend logs and alarms and energy dashboards and all that. And that's where you need the speed. You get all that information from a lot of different terminal unit controllers down below. So in a large building, you have maybe 2 or 3 or 1,000 of your unitary controllers all using BACnet Mstp. You have several BACnet routers. Each router is going to talk to maybe anywhere from 60 to a couple of hundred terminal unit controllers, BACnet controllers out in the field. And then you maybe have 1, 2, 10, a dozen of your BACnet routers bringing all that information, again, aggregating it then to the BACnet Ethernet or BACnet IP running on Ethernet. You can see in this diagram, I do have a BACnet gateway shown. Sometimes BACnet systems do need to talk other protocols. Not everything speaks BACnet today. In an ideal world it would, but sometimes you might need to go talk to an electric utility or an emergency generator set. So a lot of times those do not today use BACnet. So sometimes you do have to have a gateway type device to go talk to some of those disparate protocols that are out there, and I'll cover that a little bit more when we talk about native BACnet. Okay, next thing is the BACnet device types. You'll hear about this sometimes, things such as application-specific controller and building controller, and what all those mean. Well, you'll also see in the BACnet standards things that are like B-AWS or B-OWS or B-SS, and all those are talking about is a minimum set of objects that have to be in that device. That's really all those things define. For example, a B-SS is a smart sensor. That could be really applied to anything, but it was designed to be a smart sensor. And it said, all right, anything that's called a smart sensor has to have a minimum set of objects in it. The biggest one is analog input. It has to have an analog input object. Now, you go all the way to the top one here, BACnet Advanced Operator Workstation or Operator Workstation. An Operator Workstation has to talk to everything. So it basically has to have all of the objects and properties that are defined by the BACnet standard. It has to be able to do all of them. But a smart sensor doesn't, of course, have to do that. A smart sensor doesn't have to have time schedules or alarm handling or other things in it. It just has to have really just an analog input. Moving up the food chain, you might have a application-specific controller. Now that term is a little bit misused in BACnet and the industry, I think. When they speak of application-specific controller, they're not saying that it is a non-programmable controller. In the BACnet world of things, application-specific controller just means that it has a minimum set of objects. It has to have analog inputs, binary inputs, analog output objects, binary output objects. It also has to have schedules, BACnet schedule capability in it. If it has those minimum set of objects, it can be called an application-specific controller. But it can be a fully programmable controller too. It doesn't necessarily mean that it's configurable only or specific to a particular application. You come up the food chain up to, say, like a building controller. Building controllers have to have a lot more objects in it. They have to have routing capability. It has to have inputs and output objects. So it has, again, more objects available in it. It does more functions within a building. So you can learn more about all of those on the BACnet.org website to actually learn what's in all of those, but that's all it's specifying. It's not specifying a specific piece of hardware. It's specifying a certain minimum set of objects and properties that have to reside within some type of device. Okay, another pop quiz. You guys all had your coffee this morning, right? I found a Starbucks at 5:15 this morning, so there wasn't one open. An analog input object in BACnet is what? A, B, or C? Yeah, it's an object. Which BACnet LAN type was is the least expensive? Yeah, Mstp is currently the least expensive. Now, in the future, it might be that Ethernet becomes one of the least expensive. Really depends upon the technology of the day. And that's one of the nice things about BACnet is that it does specify multiple LAN medias, and of course, it's evolving as well. The BACnet standard is evolving. One of the things we'll talk about here is the BACnet testing laboratories. Of course, everybody has to be able to prove, and one of the premises of BACnet is that these products are all interoperable and interchangeable, but how do you know that it really is? Well, there's a company, actually several companies that are controlled by the BACnet testing laboratories, and they have set up 2 or 3 different testing laboratories now around the world that actually will test the products from a manufacturer. So a manufacturer takes his product, his new workstation or his new smart sensor, or whatever it may be, and they send it off to BACnet testing laboratories who then test it against the standard and make sure and certify that that product does use the BACnet standard correctly. It has all the properties of the objects that are in it. If they're calling it a smart or advanced application controller, it has all of the objects in it that are made for an advanced application controller. It could have more, but it has to have all of those, and that's really what gives you the interoperability as long as you're using products that are tested and certified by BTL or BACnet testing laboratories as being a proper operating device. Now you can get that if you go to the BACnetinternational.org website. You can actually find a link to the BACnet testing laboratories and see all the different manufacturers that have BACnet devices. Now these are all the devices that are certified, I should say. All the devices they have tested and certified that will be listed on there, so you can find your favorite manufacturer and check all the controllers that they have and make sure that they really are BACnet certified as being meeting the protocol standard. Now this is a term that gets tossed around, and it's been around a long time. You probably have heard of native BACnet systems before. Now this term actually came out in about 1997, just a few years after the BACnet standard was published. And what it was designed for is to identify products that were, or systems that use BACnet at all levels. If you actually bought that BACnet book or the BACnet protocol standard book from ASHRAE, it does not mention native BACnet. It was really a term that was coined by the manufacturers that says, my system speaks BACnet at all levels. And the reason why is back in 1995, when the standard was first published, almost immediately some people came out and said, well, we have a BACnet system. And it was mainly because one gateway in their device would speak a few BACnet points. The rest of it was all proprietary system. And they said, well, it's a BACnet system. It's BACnet compatible. Well, the manufacturers that had a full BACnet system where it had BACnet at all levels, all components of the system spoke BACnet, they coined that term native BACnet to help differentiate themselves and give a way for that building owners and facility operators knew what they were getting when they're buying a BACnet system. They'd say, well, if it's not a native BACnet system, you're missing out on all the good things about BACnet. But of course, you do have to have proprietary occasionally. Maybe you do have to talk to that gen set. So it doesn't necessarily mean that no other protocols are used. It means that majority of all of your main control components are using the BACnet standard. You're using BACnet up here at the management level. So your operator workstation speaks BACnet. You're using BACnet at the integration level. You have BACnet routers and building controllers. And you're using BACnet down here at your field level. And one of the real powerful parts of being a native BACnet system is that, 5, 10 years down the road, maybe you don't like that operator workstation you bought with the original system. You can actually replace it. You can replace it with a BACnet operator workstation by a different vendor. And you can only do that because the original system, that's what it used. It uses BACnet at all levels. You can also, with a native BACnet system, a native BACnet system, you can expand it. Then down here at the Mstp level, you can expand it. You can replace those controllers, again, because it's BACnet at all levels. So that's really what native BACnet stands for and where it came from. Of course, the BACnet protocol is controlled by ASHRAE, and it continues to evolve, originally published in '95. Since then, it's had 53 different addenda to add things such as BACnet IP. It's also added things such as the different device types. All those things have been added to the protocol and the standard. So it continues to evolve. And it's evolving using ASHRAE committees. Now there's a bunch of different working groups. If you go to the BACnet.org website, you have information about all these different working groups, and you can actually join them if you'd like. But there are working groups looking on how to expand BACnet Mstp, for example. How do we make that work at a higher baud rate? There's working groups talking about smart grid. How do we bring smart grid and automated demand response, which is part of the smart grid? How do we bring that into the BACnet standard? So there's groups, they publish their findings and have a review period on a new addendum to the standard, and those come out just about yearly. There's new addendums to expand and make the standard better. But the standard is always 100% backward compatible too. So if you bought a system back in 2000, that it was a version of BACnet that was made in 2000, it's still compatible with the new systems today. It is backwardly compatible. So just because you have an older system does not mean that it's not BACnet anymore. It still is BACnet. There's a lot of vendors today. It's also a big strength. There's over 685 different BACnet vendor IDs. Now, BACnet vendor ID is a number, basically, that gets every controller and workstation and everything that a manufacturer builds for BACnet. It has to have that BACnet vendor ID built into it. That way, if vendor A's workstation goes out and talks to vendor B's BACnet device out there and says, all right, who are you? What's in you? That's one of the things that it can come back to. It says, well, I'm a controller. I'm this type of controller. I have all these objects and properties in me, and I'm made by manufacturer Y. So there's actually all these different BACnet vendor IDs.
Are there numerous discovery tools that can go out and find devices?
Yes, there are. I would say all of the operator workstations today that are on the market made by all the different manufacturers, those do. And then there's also third-party device products too. They're not really manufactured by one of the manufacturers of a BACnet control system, but they're third-party devices by a number of different manufacturers that'll do the same thing. Automated Logics has one, but they're a manufacturer. But there are, well, I think Cisco has one. Let's see, Ben, you know of any others that are out there? There's a number of different manufacturers of software-based systems that will go out and query a BACnet system and show you all the different devices that are out there. And again, since it's a BACnet is the open protocol and all those objects and properties are defined, it makes it very easy for anything that understands the BACnet protocol to go out and query. It says, all right, who's out there? And all these devices will echo back saying, I am this device, and I am this device, and these are all the properties and objects that are in me. So it's makes it very easy to find that out. But there are many different vendor IDs today, 685 in over 43 countries, and that list gets added almost weekly. There's another one that gets added to that list. BACnet International Success Stories. If you go to the BACnet International.org website, you can find success stories in all the different vertical market types. So if you have a hospital or you have a school, or regardless of what type of building you have, there's going to be a success story on there, well, in a white paper that explains how BACnet was utilized in that particular building. It's a great resource to find out information about the different BACnet systems that are out there and how they were used, how they were implemented. One of the ones, a couple of these actually are going to be up for a potential award today at the award ceremonies at 2:45 for BACnet International. One of those potential ones here is the Bullitt Center, which is a living building that was built in Seattle, Washington. It meets the Living Building Challenge, which means that it's off the grid for both water, sewer, and power. Composting toilets and things like that. It's kind of interesting. So we've talked about all of it. Now let's bring it all together, and what really are those strengths? Well, multiple LAN types really give it a lot of strength, because you're not limited to just one LAN type that has to be used in all the different areas of the system. You can use Ethernet, you can use IP WANs, you can use MSTP, you can use ArcNet, and it's all BACnet, and you can use the correct one for the the type of mechanical equipment, the type of controller, the point density count of the controller that's required. So that's really a great strength of BACnet, is that it has all these different LAN types. Again, all the objects and properties of those objects are all specified. It's all part of the standard. And that allows what we were talking about a moment ago, which is called auto-discovery. The operator workstation or any other building controller and a lot of devices that can ask who is, there's a message called a who is message, they can send that out, and all these devices will echo back, I am device number such and such. I'm made by this manufacturer. These are all the things that are in me. These are all the objects and properties that are in me. So it allows for auto-discovery. Makes it very easy to expand a system, because you can add a controller into a BACnet system, and it'll automatically, when it gets powered up, it'll say, I am this, and everybody all the other controllers in the system can learn about what that device is, and it can be added in very easily without knowing anything else about that product. You don't have to know what's in it ahead of time. You can connect to it, and it'll tell you what's in it. Also, since all of the higher level services, such as schedules and trend logs, are defined in the standard, it also allows all those schedules, trends, and alarms to be very similar. All the manufacturers do it fairly much the same way. So you'll find things like going from a BACnet system made by one vendor to a BACnet system made by a different vendor. Your schedules, trends, and alarms will all look and handle very much the same, which is a really great strength in the system. You don't have to have as much or as steep a learning curve when you move over and start working with a different BACnet system by a different vendor. Again, created by ASHRAE. So it's governed, controlled by ASHRAE, will be forever. That allows it to continually adapt. It's backwardly compatible, and it really helps ensures the longevity of that system. So if sometime out in the future, you don't have to worry that system will no longer be supported. If you bought a BACnet system by vendor A, and maybe vendor A goes under, or they get bought by somebody else, and they stop making BACnet products, well, you don't have to really worry too much, because you can still buy a BACnet product from some other vendor that makes a product that will be replaceable. So you no longer have to replace the whole system. We're actually starting to see that today in some of the proprietary systems that were made back in the 80s. Some of those manufacturers no longer support them, and you can no longer buy controllers. And you're being told, well, if I'm sorry, your VAV controller failed, we really can't fix that. We can make a standalone one there, but if you want it to be part of your building automation system, you're going to have to replace your whole building automation system. And with BACnet, you're not going to have that kind of a problem, because at some point in the future, you can change that VAV controller out with a different one made by another manufacturer. Is it plug and play? No. But the contractor can look at the rest of the system, put the sequence of operation in it that matches the sequence of operation of the existing system, map all the points to the right objects and properties, and they can make it work, and they can replace that controller with a different brand. So you get that longevity is fairly well ensured. Worldwide acceptance. We talked about the number of manufacturers all over the world doing it today. So regardless of where you go, that's a real strength. BACnet's here to stay. Because of the auto discovery, you end up with a lot easier startup on these systems. It's easier to integrate in your automation system to the boiler or chiller pack that may have information in it. And again, not being tied to specific hardware with hidden costs that may be associated with is also a great strength in the BACnet systems. Some of the weaknesses, though. Well, one of the weaknesses is the developer tools. The BACnet standard does not, as published by ASHRAE, does not cover the developer tools. So every manufacturer makes their own development tools. The development tool is the software that runs somewhere in the system that's used to program the controllers, put the specific sequence of operation into those controllers, and also probably to create the graphics on their workstation. But that standard is not part of the BACnet standard. So they're all different. So if you bought an operator workstation or an operator workstation by vendor A, it may not be able to reprogram or program a controller by vendor B. So one of the things you want to make sure you get is that you get the development tools with your system. If it's not supplied initially, make sure that you buy it and get it from them. Make sure that before you buy and specify a system that you can get it. You can get that and own it yourself. Because if you have the development tools, now you're no longer tied to have to go back to that contractor, because now you, or maybe a different subcontractor, different control vendor, can sit down and use those tools to maintain that system and reprogram it as your building use changes over time. Another pop quiz. I thought we were done with these. Okay, what website has information on BACnet products? Yeah, BACnetinternational.org. That's probably one of the best places. There's a few others out there, but that's really the definitive standard. They have information about. From there, you can also go to the BTL and see all the devices that have been tested and certified as being BACnet devices. So I kind of gave this one away. Who tests and certifies BACnet products? Well, it's not ASHRAE. I'm not picking on Johnson. I used to work there. BACnet testing laboratories. Okay, some of the obstacles to interoperability. Configurable only controllers. You have to be a little bit careful. Configurable only controllers, what I mean there is they're not programmable. You cannot rechange the sequence of operation inside that controller. Now, configurable only controllers are good as long as you're using them in the proper place and they have what you're going to need into the future. But if you're using it on a larger system that may need to be modified, such as a boiler or chiller pack, it gets a little bit more difficult in the future to actually, as new ideas on how to optimize a chiller come out, you may not be able to reprogram that controller. So configurable only controllers can be a bit of an obstacle. And sometimes you might actually be buying a controller that does not meet local codes. For example, in California today, if you have an air handling unit with an economizer and you want to have a building permit that has something to do with that, maybe you're remodeling it or putting in a new air handler, guess what? You have to have California Title 24 now takes effect, and you have to have demand control ventilation. That also means that all the equipment that's being supplied by that may need to be bringing information back up about CO2 levels for that demand control ventilation. But if all those controllers are configurable only, it may be more difficult to add those kinds of things into that building automation system. So just be wary of configurable only controllers. They're great, they're lower cost than fully programmable, but you need to, especially on larger pieces of equipment, you may want to go with fully programmable controllers. Again, the DDC system programming tools, a lot of times they are provided, but the owners are locked out by passwords. So make sure, number one, that you have the system, that you actually have those programming tools, they're provided, and you have access, and you have the admin level passwords to get in and use that, so that you can do it. Also, you can allow a different service company, for example, to sit down and use those tools to modify your building's control system. Package systems. A lot of the package systems today, we're starting to see that more and more often. I'm certainly guilty. The company I work for, we make DDC controller boards for a lot of rooftop units and things like that. And those people want to control their sequences. They want to make it so that that sequence only works a particular way, and that's done for really good reason. They don't want people coming in there and overriding and changing the program that might get rid of some of the safeties that are involved with that piece of equipment. So that's one of the reasons why they prevent them from being programmable out in the field. So they have to, those are more configurable. But you have to really be a little bit more cautious because they're sometimes not tunable. They may not evolve with your building, so that later on if you want to add demand control ventilation, it's going to be more difficult. So my advice here is to make sure that you understand what you're buying in some of that packaged equipment. And if it's not going to meet your future needs, you might want to go with programmable controllers that are in that packaged equipment, which would be normally done by your local building integrator or building contractor, controls contractor. One other thing too, back over here to the packaged systems, is a lot of times they're difficult to commission. Commissioning agents are having a difficult time today getting the sequence of operations for packaged equipment. The equipment supplier isn't really a controls contractor, they're just providing the equipment, and they don't know very much about how the thing is programmed. So it gets more difficult for the commissioning agents to get that information. So before ways to overcome it, before purchasing, make sure that you review the sequences that are coming with packaged equipment. Perhaps go with programmable controllers instead of or just configurable controllers. Make sure that you have or provided the administration level passwords to that building automation system. It's yours, you own it. Make sure that you're given all of the access to it, and don't allow that controls vendor to lock you out of certain parts of it, which happens quite a bit today. So it's your system, don't allow them to lock you out. Make sure all those tools are given to you. And then also in new construction, if you're going through the new construction process, one of the ways you can overcome some of this interoperability obstacles is make sure that before the construction starts, you get all of the controls, contractors, and integrators, system and equipment suppliers, especially for that packaged equipment, you get them all together along with the commissioning agent. You have them all sit down, review the building design, make sure that it meets the intent, and that their sequences meet that those sequences. Too often today what we're seeing is that rooftop equipment with packaged equipment shows up on the job site, and the commissioning agent goes to commission the system, and guess what? It doesn't have a sequence in it that it's supposed to have, and it's too late. It's really too late at that time. So make sure that you get the sequence of operation up front. Make sure that those sequence of operations are provided, and the commissioning agent reviews them and approves those sequences so that it's going to meet the needs of both the local building codes and the building as it's designed, and also for future needs. And that's all I have to say. So, any questions? Yes, Grant. Very good. All right, well, thank you. We'll make sure you fill out the, oh, there's another question back here. I'm sorry. Go ahead. Okay, very good. I have business cards up here if you like. Be sure for the CE credits you fill out the evaluation.